Welcome to the video. Here we're looking at a distribution of values that's normal, so that's a key piece of information, with a mean of 120 and a standard deviation of 20. And we're going to draw from this distribution samples of size 36. And we're interested in the interval containing the middlemost 34% of sample means. So let's start out by sketching some of the information and just organizing the information we've got. When there's this much information in a problem, and even as we go on there'll be even more information in a problem, a great way to begin is just summarizing it so you can get at it quickly. So we have a normal distribution with mean 120 and standard deviation 20. And the sample size they're talking about, 36, tells us n equals 36. So it's nice to have all that information somewhere we can get at it quickly. Now they're looking for the interval containing the middlemost 34% of samples. So let's draw a picture and see how that 34% fits into the picture. I'm going to sketch my horizontal axis and my normal curve, and I'm going to write above it the given information of the mean of 120 and the standard deviation of 20, and I'm going to note I'm taking samples of size 36. So for this sampling distribution of the mean, the standard deviation is not 20. It's 20 divided by square root of 36, because we're looking at the sampling distribution of a mean, right? They're talking about sample means. So the mean of that distribution is the same as the population mean, 120. And now they're looking for the interval containing the middlemost 34% of sample means. So let's shade that in. That 34% is an area in this picture. It's going to be an area in the middle of the picture. Is it a long, skinny area? Is it pretty wide? Well, we can remember that our empirical rule tells us 68% of values are within one standard deviation of the mean. So 34% of values is going to be smaller than one standard deviation away, and we can just kind of eyeball, something to keep track, something like that. We don't know what these numbers are yet. If we knew those, we'd be done with the problem. So those are the numbers we're looking for, and here is the area that we were given. So this area we know is 0.34. So to find these numbers given an area, we can use that inverse norm command. But keep in mind, when we use the inverse norm command, it always wants us to tell it the area to the left of the value of interest. So if we were looking for this value of interest here, we would have to tell it this value right there. So let's figure out what that area is. What would this area be in green? Well, one way we can think about it is to say the total area under the curve is 100, or 1 as a decimal, and the red area is 0.34. So 1 minus 0.34 tells us what's left over. Tells us there's 66% of the area left over, but that isn't all 66. There's two sides left over, these two sides in green. They're equal because of symmetry, right? This is the middle 34%, so this side must be equal to that. So if we divide that 0.66 divided by 2, we're going to get 0.33. That will be the area right here, and by symmetry, this area would also be 0.33. And you can just check and make sure they all add up to 100 again. If you add to 1, if you add 0.33, 0.34, and 0.33, that'll all add up to 1, so that's good news. All right, so let's go ahead and do our calculation now. Let's find this side first. So we can use the inverse norm command, and we enter the area to the left, so that's 0.33, and the mean, which is 120, and the standard deviation, which is 20, divided by the square root of 36. You might notice that that's 6, so you could put a 6 in right there, or you could keep it as square root of 36. It's going to come out the same either way. So we'll do second vars, inverse norm, option 3, and then put in 0.33, comma, 120, comma, and then 20 divided by the square root of 36. And the answer I'm getting is my pen's not working. The answer I'm getting is 118.5336. How many? Your numbers should be accurate to one decimal place in our final answer. So it's going to be 118.5. That's this number right here. So we'll say 118.5. Now there's a couple ways we could think about to get that second answer. One thing we could notice is this is symmetric. So however far this value is from the mean, this number must be the same distance. So 118.5 is 1.5 below the mean. So this number must be 1.5 above the mean. So we would expect this to be 121.5, but let's show how we could also get that answer on a calculator. So we want to do this on the calculator. We could enter inverse norm. Now we need the area to the left of this red question mark. So to the left of here is this 0.34 area and this 0.33 area. So if we add those together, that gives us 0.67. So that's the area to the left of this value of interest, 0.67. Our mean is still 120. Our standard deviation is still 20 over the square root of 36. So we'll go ahead and calculate that. Second vars, inverse norm, 0.67, 120, and 20 divided by the square root of 36. Oh, didn't use the right square root key there, square root of 36. When I do that on my calculator, what I get, 121.466, so that rounds to 5, so it's 121.5. And the last thing to notice here is they're asking for the answer as an interval. They want us to enter it in interval notation, so we need to use parentheses and enter the left-hand value, 118.5, then a comma, and then the right-hand value, 121.5. and then another parenthesis. And it's always nice to take a minute and think about what that means. What is that interval telling us? It's saying if I have a population with mean 120, standard deviation 20, and I take a sample of size 36 from that population and look at the mean of that sample, 34% of the time the mean of my sample will be between 118.5 and 121.5.